Hi guys, how's it going? So today actually we're gonna be going through a system design content. So we're gonna be designing Twitter search. So you can think of Twitter search as a service that is going to enable the user to search for tweets based on a specific query. So if we have a client here, they can write a query, and this query can be multiple words. And what they can do is that they can hit our backend services, and which will then have to return all the relevant tweet based on the search query, right? Based on that definition, what are the key requirements and estimates that we should know before we go into build this system? So I'm gonna assume that on average we have 500 million searches happening every day. 500 million searches every day. I think this is quite reasonable. If we assume that Twitter has over a billion of users, 1.5 billion users, and among those 1.5 billion of users, only 500 million users are active. So this is going to be our DAU, daily active user. Okay, so for some of you guys, these numbers might not be quite correct to the current system Twitter is using. I think their daily active users around 500, less than 400 or so, and the total number of users I think is also like 500 million or so. But roughly somewhere around there. But I thought like I'm gonna like double the numbers so that we can be able to create more of a robust system overall. Anyway, I'm gonna also assume that Twitter gets 400 million of tweets a day, right? So 400 million tweets every day, and also, like we said, our search query is essentially going to have multiple words. So people are allowed to search for tweets having multiple words, right? And because of we know that Twitter has a limit on the character that one can type. For example, I think it's 140. So we're gonna assume that each tweet is gonna take us 300 byte. Right, 300 byte. So based on these things, based on these components that we just spoke about, let's estimate the storage and the system capacity, right? So we're gonna estimate that the storage capacity, because we said that we have 400 of tweets, right? 400 million of tweets coming in every day. And we know that each tweet is costing us 300 byte. So we're gonna say 400 times 300 byte, which should put us at roughly around 120 gig per day, right? I've already done these calculations, guys. So don't think I'm a magician or anything like that. So anyway, because of this, I wanna say that the bandwidth it's gonna be we're gonna take this and we're gonna divide it into to a second. So it's gonna be 120 gig divided by 24 hours and 3.6 seconds, which will give us 1.3 megabyte per second, right? So what are the API parameters that one should expect for building such systems? So we're gonna have so we can assume that internally our services will communicate through an RPC, and we're going to expose the REST APIs to the end user, right? So our search API will essentially take the dev API right? And it's going to take the search terms or the query, and we're going to have the maximum number of tweets that we can return, right? We're going to have the sort. If the user selects to sort by instance, most like, match, or something like that. So, and we can have a page token. So this sort could indicate if like we want to sort by like, we want to sort by match, etc, etc, right? So what we need to return, we just need to return a JSON containing the number of tweets. Okay. So number of tweets. So that's how the SH API is going to work. So now we can look at the high level picture of the system. So essentially we're gonna have some sort of like clients, right? And we're gonna have an application server, and we're gonna need to have an index. So we can think of like we need to index all the search queries against all the relevant tweets, right? So, and we're gonna need to store all of these tweets into this database. So we store all of the tweets in the database, and we index where it's appearing in the tweet. Okay, so here gonna be our database. Okay, so this is like all the at the high level. This is like our architecture. So now let's get into detail and more in depth of how everything will flow. So we know that we are storing over like 120 gig of tweets every day, right? Because of this, we're gonna need a partitioning service, right? So that will distribute data into multiple servers. So the data will need to be distributed to multiple servers, right? To maintain a fault tolerant system, we need a copy of tweets also. So for instance, to make sure that if one server goes down, we still have those tweets. So we need to maintain a fault tolerant system. We need a copy of all the tweets. So how does this one roll out? So given that we have 120 gig, and we're gonna multiply it by, because this is a day, so we're gonna multiply by 365 days, and we're gonna multiply it by 5 years, right? We get 200 terabyte. We multiply this by 2 to maintain the copy factor, so that if one server goes down, we still have the data. So we end up having 400 terabyte. So with this in mind, we know that a modern server can take 4 terabyte, right? So if we take the 400 terabyte, we divide it by 4, we need 100 servers to store, right? Given that we need to partition our data into like different servers, let's assume that we have MySQL database, and whereby we have some like column which is tweet ID, and we have text, right? To keep it simple, let's assume that we have 2 columns. So for us to partition this data by tweet ID, we're gonna use tweet ID. So we can think like we're gonna take a hash function and we take a tweet ID, then this hash function will tell us where in which server this tweet should go, right? It's gonna tell us. But now, because we just said that for us to partition these in a very even manner, so that means that this tweet ID should always be unique. So the question now will be, how do we create unique tweet ID, right? Given that we are working with distributed servers, right? So, and we know that, for instance, we're getting like 400 million tweets a day, right? And if you multiply this by 365, multiplied by 5 years, we're looking at 730 billion IDs, right? So we can assume that we have a tweet ID generator. Okay, so I'm gonna touch on the system design, guys, for generating IDs. I think there's multiple options like snowflakes. I think Twitter is using it. I'm not sure, but yeah, I think it will be quite an interesting system design content. Just to walk you through how these complex systems they generate IDs in a distributed environment. So the index part of things, essentially its job is to say we have two queries that are text-based, right? So it should tell us which weight comes from which tweet, right? So that's like the point of this. So since we know that tweet queries, right, will be text based, so the index function is to tell us which weight comes in which tweet. Okay, so because now we're going to rely on knowing which weight come from which tweet, we're gonna need to create a vocab of weights. So we're gonna say the index size is gonna be equals to, so English vocab is gonna be 300k weights, right? And we're gonna say plus noun, things like names, we're gonna say it's 200k, which will give us 500k of all the terms that we can come across as like the user searches on the system. So assuming that one character equals to 1 byte and on average name length is equals to 5, so what will then be the size of this vocab? So I'm gonna say, let's assume that one character equals to 1 byte, and because we know that we said that we're gonna store all the English weights, right? So on average the weight length, it's gonna be equals to 5. Then we can take 500k, right, multiply by 5 byte, and we end up with 2.5 megabyte in memory. of all the weights. So the point we're making this, guys, is that obviously we're gonna get a search query, right? Like let's say someone search COVID 2019, right? The obviously we're gonna do some sort of like data cleansing. I think maybe to remove stop words and numbers and stuff like that. But so what we need to do is that we're gonna break all of these weights that are in the search query, right? And we're gonna push them into our vocab to see that which tweets are associated with this query. So all of the tweets that have this term COVID. So hence, that's why we need to store all of these words as a vocab. We need all of them because we don't know what the user will search, right? So the best way to do is that to store all of the possible words that will occur in a query. So because of now the user is searching for tweets, they can search for tweets for like from 2 years, right? So we're gonna say if we want to keep index for all the tweets from 2 years ago. So indexing of tweets, this is how we'll go. We know that we have 730 billion of tweet ID, right? But this is for 5 years. So if we estimate this into 2 years, we're gonna get roughly 200 billion. So yeah. So if we take 200 billion of tweets, then because this is tweet ID, I'm taking this 730 billion from the number of tweets per day that are generated. So we know that for 5 years it's going to be 730. So I am taking that and I'm saying that I don't want 5 years, instead I want 2 years, because we're going to index 2-year tweets, right? So now I'm saying that, okay, now we have 2 years tweet, which is going to be 200 billion. Then I'm going to say times 5 byte, right? Which is going to give us 1 TB tera. So which is approximately 1000 gig, right? So this is quite a lot. So how would you then store this? We're gonna need a distributed service to store all of that. So how will this work is that we can think that we have a distributed hash whereby we have a key and a value. So one way we can go about this is that we can keep all the weight on the key and we can keep all the tweet on the value ID. So the key will be the weight and the value will be the tweet ID of the tweets that contain the weight. So if this is COVID, right? If we assume that this is COVID, then we assume to see all of the tweets here that have that tweet ID, right? I hope that makes sense. But now, because of this, because we know that tweets has like multiple weights, right? And we can make assumption that on average a tweet has 15 weights, meaning that tweet ID will be stored multiple times, right? Because we have weights here, then we have another weight, maybe let's say China, right? We have that tweet ID, the same one, because it had multiple weights. So because we said that on average each tweet is 15, So then, which means that we're gonna take our terabyte, then we're gonna multiply by 15. Then we're gonna add the 1.5 of the vocab, 1.5 megabyte, then we end up with 15 terabyte. So I'm taking this 1 terabyte from the estimated storage of all the tweets, right? But because we need to store the tweet multiple times, tweet ID multiple times due to the weight, right? Remember that a tweet, for example, let's say I'm saying happy new year, right? I'm saying happy new year. So this is a tweet ID. Let's say it's tweet ID number 5. Because it has happy, under the key whereby we have happy, I'm gonna store that tweet 5. So let's say we have happy, right? I'm gonna say, okay, tweet 5 had this thing called happy, so it's gonna be tweet 5. Then I go to new. Under the word new, I still have to store tweet 5. So you see that I'm duplicating this. Here, I still need to store tweet 5. Hence here we're saying that out of all the tweets generated, we multiply them by 15 because on average we're assuming that each tweet is going to have 15 words. Then we get 15 terabyte. So that's where we deriving that from, right? So this is quite expensive. We need some techniques to know how we can actually be able to distribute this data across different servers. So because of this size, so you can tell that we're going to need to build something that is distributed, and we need to come up with techniques on how we can distribute this. And this is also, by the way, it's also known as big distributed hash table, right? Big distributed hash table, right? So one way we can ensure that our data feed in one server, so we can use not necessarily in one server, but given that we have like this size, we can distribute the data across multiple servers in such a way that it can fit, right? So one way we can technique is that we can use sharding. So we can shard our data based on the weight. So the idea here, guys, is that if we get a search query, for instance, let's say someone search for something like happy new year, what we do is that we iterate through all of these words, right? Say for each word, we want to hash the word to go to a specific server. So this is going to have its own server. And remember that each word, we said that it goes in hand with tweet ID, right? So meaning that on each server, let's say here happy, we're going to have tweet ID. What is it? We said new year. Let's say this was hashed here. It's going to be tweet ID. Maybe we have a year. Maybe this was hashed here. Going to have tweet ID, right? However, when we search, it's gonna happen. We're gonna do the same thing. Let's say we have we're searching for tweet like Happy New Year. We're gonna have to go through these servers, right, and retrieve all of the tweet IDs that matches this query, right? But can you see the problem with this is that what if we have a very, very popular word, for example, like let's say it was 2019 and we have people were tweeting about COVID. People were searching this term probably on Twitter. So what's going to happen is that every time everyone searches, we only hit one server. All the request goes to the server, right? Given that we said that we have something like 800 DAU, right, and we have like 500 searches every day, and let's say 50% of the searches, right, searching the word COVID because it was the popular word, maybe 2019, right? you can tell like we're going to overwhelm this server. We're going to overwhelm because like we have like over like 200 something servers, but one server is taking 50%, is handling 50% of the search queries, so it's gonna go down, right? So can we do something better about this? Can we probably like think of a way we can um, we can still be able to shard and get the better performance, right? Um, so one way we can go about this is that we can probably shard on the tweet ID, right? So if we shard on the tweet ID, the goal is that we're going to store all the tweet words in one server. So if we say hash tweet tweet ID, essentially all the words are going into one server, and all the words of the tweet are going to be in one server, right? So this way, if we get a search query, right, if we get a search query like happy, we're going to have to search a set of servers, search a set of servers to retrieve the relevant IDs, to retrieve relevant tweet IDs, right? And to make sure that our system is more robust and can scale, we can use a consistent hashing to make sure that the number of servers does not necessarily affect the hashing mechanism that we have, right? And I didn't explain that why we needed to shard. For some of you maybe might be confused why. So we need to distribute this because like on average a memory can take on one server can take something like 144 gigabyte, and we have more, hence we needed to do this. Okay. Yeah. So coming to optimizing our system, we can have a cache. So we can say that to stop hitting our database directly, we can cache all the hot tweet, right? This is going to enable us to not overwhelm our database, right? And we can use an LRU policy. Another optimization that we can have is to have a load balancer. So we can have a load balancer between the client and the application server, and also here load balancer between the server, the backend server. Then here we're going to have a load balancer, right? So one of the techniques, we can have round robin. However, round robin, the problem with this is that it does not take into consideration the weight of the server. So intuition or maybe assumption is that some of the servers will be slower than others. So what we can do is that we can use a weighted round robin. But by the way, if you guys don't know this, so you can think of this as a load balancer that, let's say you have multiple servers like so, right? So what it does is that it goes in round, it sends request here, it sends request here, it sends request here, it goes back, it sends request here, it sends request here, it sends request here. But you see what's the problem with this is that if this server here is slow, right, to process, then as much as you keep on rounding these, this server might become so slow that like you start sending requests to it again while it's still processing another request. So hence we say that we use a weighted round robin. This one will make sure that it sends this request to more requests to the servers that can handle more, that are more fast to handle, like, so that's why we're using this. um Check my second channel, guys. I have my second channel, so I'm gonna build this thing, but I'm gonna build it from a machine learning perspective. So we're gonna see how we go about it, but um it's gonna be called ranking. Check my second channel. I'll leave the link. I'm gonna do a system design for this, and the thing that I want to do is that I want to approach it also from a software engineering. Not only talk about vector database, but I don't talk about how that distributed or anything. So I want to get into the meat of like distributed systems, but also from a machine learning perspective. So it will be cool actually to do it that way, so that like software engineers can see how machine learning is still relevant in software engineering overall. So yeah, I'll probably, guys, keep you updated on that one. But that's it, guys. I really appreciate you guys for staying and watching to the end. I'll see you in the next one. Thanks. Bye.